Hey everyone, this is Jay, and in this video we're going to talk about the basics of fats. This is another supplementary video for my classmates to help with a general understanding of nutritional concepts, but it's being made available publicly in case others may find it useful. A lot of this information is not in the textbook, but I found that it's very helpful to understand the fundamentals of a subject in order to grasp its many details that the book throws at you. And perhaps more importantly, this is the kind of good information that will help you moving forward, not only in your career with your clients, but even in your own personal lives and dietary choices. Let's get going. When most people think about fats, what often comes to mind are the usual culprits, most of which we mentioned briefly in the Nutritional Basics video. You have your saturated fats, monounsaturated fats, and polyunsaturated fats, hydrogenated and partially hydrogenated fats, your fatty acids and trans fatty acids, triglycerides, oils, and some of you may even associate fats with things like cholesterol and certain lipoproteins. These are what most people think about when they think about fats. But here's a question. Which of these are good for you and which are bad for you? And more importantly, for those of us looking to work in the healthcare industry, why exactly are they good or bad for you? In this video, we're going to answer these questions. To understand the answers, we'll need to learn about fats from the ground up, and by that I mean starting with their chemistry. But don't worry, it isn't nearly as complicated as you think. Fats, like carbohydrates, are all made up from just three chemical elements: hydrogen, carbon, and oxygen. And going back to the very, very basics of chemistry, hydrogen has one covalent bond, which we'll draw like this. Carbon has 4 bonds, and oxygen has 2 bonds. Even if you don't remember much about your basic chemistry, none of this should come as a surprise to you. These bonds are what allow hydrogen, carbon, and oxygen to form many of the common organic molecules that we all know and love, such as water and methane. But sometimes these bonds can double up, such as with carbon dioxide, like this, with double bonds between the carbon and the oxygens. And that's all we need to know, really, because now we can take a look at this monster of a molecule. This is a chain of carbon atoms, where every carbon in the chain is bonded to either hydrogen or another carbon in the chain, and at the end of the chain, there's what we call a carboxyl group. Now don't let the fancy name fool you. A carboxyl group just looks like this. The carbon is double bonded to an oxygen and single bonded to a hydroxyl group, and hydroxyl group is just a fancy name for an oxygen and a hydrogen. And this is what we call a fatty acid, a chain of carbon atoms surrounded by hydrogen atoms with a carboxyl group at the end. All of the fatty acids that are important to our nutrition have their own names, and this one, which has 18 carbon atoms in this specific structure, is called stearic acid, and it's one of the most common forms of fat that can be found in lots of different animal fats, as well as a few plant sources like cocoa butter. Now, what did we mean when we said that this fatty acid can be found in different fats? Fatty acids are usually transported around the body in the form of triglycerides, which very simply are 3 fatty acids attached to a glycerol, hence triglyceride. And the whole thing can look like this. This is just 3 stearic acids bonded to a glycerol to form a triglyceride. And this triglyceride is what we typically mean when we talk about fat in the human body's adipose tissue, and also in animals, and even in vegetable fat. So that's 2 definitions down: fatty acids and how they form triglycerides. Next, let's focus on this fatty acid. Notice that every carbon atom in the chain is attached to at least 2 hydrogen atoms, except where the carboxyl group forms. In fact, at the opposite end where the chain ends, there's even 3 hydrogen atoms. You can say that this molecule is absolutely full of hydrogen atoms, that it is saturated with them. And so we call this a saturated fatty acid, and a triglyceride made up of saturated fatty acids is called a saturated fat. So when we talk about a saturated fat, the thing that it's saturated with is hydrogen. So stearic acid is a saturated fatty acid, or when it forms a triglyceride, it forms a saturated fat. Next, remember that sometimes atoms with multiple bonds, such as carbon, can form double bonds. What if these 2 carbon atoms right here instead had a double bond between them? Well, we'd have fewer bonds to be able to connect to hydrogens, so those would get dropped, and it could look like this. The double bond prevents this fatty acid from being saturated with hydrogens, and so this is called an unsaturated fatty acid. This unsaturated fatty acid is still made out of 18 carbon atoms in a chain, but now it has 2 fewer hydrogen atoms, and so its chemical formula is different. This particular unsaturated fatty acid, where the double bond appears at exactly this location and in this form, is called eliadic acid, and it's often found in hydrogenated vegetable oils, where it forms triglycerides of unsaturated fats. Some unsaturated fatty acids have just one double bond somewhere in the chain, just like eliadic acid, and so it is a monounsaturated fatty acid. But some others have 2 or more double bonds somewhere along the carbon chain, and these are called polyunsaturated fatty acids. Okay, so you may have noticed that we snuck in a new term there, so let's go back and define it. Hydrogenated vegetable oil, or hydrogenated fat. Remember, oil is just a fat that is liquid at room temperature. As you may have guessed, saturated and unsaturated fats have very different properties despite being almost the same. For one, they can have different melting points, and so one may be a solid fat at room temperature, while the other may be a liquid oil. Let's imagine that you have some vegetable oil, but you want to make a spread out of it, something that we typically call margarine. The idea is that it's made from vegetable oil, i.e. it's made from plant oils, while butter is made from animal oils. And so margarine is conceivably healthier for you. But how do you make a spreadable product if vegetable oil is made from unsaturated fats that are liquid at room temperature? Well, what you do is add hydrogen to the unsaturated fats, so they form saturated fats instead, which also breaks the double bond between the carbons and reforms them into single bonds. This process is called hydrogenation, basically because it adds hydrogen to unsaturated fats to make them into saturated fats. So then, your margarine just doesn't melt into oil when it's taken out of the refrigerator, and instead remains a soft but solid spread. And so fats, or oils, formed by this process are called hydrogenated fats or hydrogenated oils. Sometimes, though, the hydrogenation process doesn't always happen perfectly. Some fats will only have some hydrogen attached, but not all of the hydrogen that are needed to fully change them into a saturated fat. When this happens, it becomes a partially hydrogenated fat. At this point, you may point out, but I heard that hydrogenated fats are even worse for you than saturated fats, so what's the deal there? The key is here, in this double bond. You see, when the carbon chain has a double bond, it becomes inflexible and locks it into place. But there are two possible ways it can be locked. The bond can form a straight chain at the double bond, like this, or it can form a bend, or a kink, at the double bond, like this. These two molecules still have the same numbers of carbon and hydrogen atoms as one another, so they have the same chemical formula, but they form different three-dimensional structures, and so they're called isomers of one another. The isomer that forms this kinked chain is called a cis isomer, and the isomer that forms this straight chain is called a trans isomer. As you may have guessed, if an unsaturated fatty acid has nothing but trans isomer double bonds, then it's called a trans fatty acid, which forms a trans fat triglyceride. If it has cis isomer double bonds, then it's still just called an unsaturated fat. By the way, we already determined that the trans isomer form is called eliadic acid. This cis isomer form is called oleic acid, and is the primary ingredient of olive oil. As a bit of an aside, it's very common for people to say that hydrogenated fats and trans fats are the same thing, even though they technically aren't. This is because trans fats are only created in large amounts during the hydrogenation process. However, trans fats are created when hydrogenation actually fails, and so it's more proper to say that partially hydrogenated fats are the same as trans fats. You'll hear all three terms used interchangeably these days, but now that you know the difference at the molecular level, hopefully this will help you to not become confused. So now that we've set up these definitions, what exactly makes hydrogenated fats and trans fats so widely regarded as bad for you? As it turns out, a double bond being a cis or trans isomer bond makes several huge differences on how the fat behaves, and we'll talk about three of the most important differences here. First, recall that one of the reasons hydrogenation was developed was to make oils no longer liquefy at room temperatures. In large part, this is because those saturated fatty acids form straight molecules that can be packed relatively close together in layers. This often keeps them a soft solid, but still a solid, at higher temperatures, meaning it raises their melting point and makes products like butter and margarine spreadable. Straight-chain trans isomer fats also end up being able to pack together very well, with a high melting point. Many trans fats have melting points at around 45 degrees Celsius, and they can often stack together even better than saturated fats. And that is the key. Remember that our body temperature is about 37 degrees Celsius, so having triglycerides in your bloodstream that both tend to be solid at your body's internal temperature and are very good at creating plaques on arterial walls is not at all a good combination, and both saturated fats and trans fats can do that. In fact, trans fats are often even better at it and thus are worse for you because they can form even more tightly packed structures, and also because our bodies have a much more difficult time breaking down or metabolizing them. This is because while trans fats may occur naturally, especially within ruminants, they are still quite rare, and thus our bodies never needed to be good at dealing with them. But then, starting around the mid-20th century, hydrogenation became more widespread, and so did the presence of trans fats in our foods. Finally, the third big drawback with trans fats is that they have been seen to react poorly with lipoproteins. In particular, it raises LDL levels just like saturated fats, but unlike saturated fats, it also lowers HDL levels, which is pretty much a double whammy when it comes to serum cholesterol and atherosclerosis, and is linked to increased risk for coronary heart disease, disrupting metabolism of essential fatty acids, and is under investigation for possible links to obesity, diabetes, liver dysfunction, and others. Because of all this, back in November 2013, the U.S. Food and Drug Administration, after many years of research into trans fats, declared them as not, quote, generally recognized as safe, unquote. And then on June 16, 2015, they formally banned trans fats from all foods sold in the U.S., requiring that they be eliminated completely within 3 years. While these days, meaning around April 2017, it's really difficult to find any trans fats in any US products, you can still find a few if you look hard enough, especially for cheaper imported foods. So keep an eye open anyway and avoid them. For those of you keeping track, the deadline on the trans fat ban is officially in just a little over 1 more year, on June 16, 2018. Okay, enough with the doom and gloom. We keep hearing that some fats are good for you and even required to be healthy, so which ones are those? Well, you always need a small level of fats, preferably polyunsaturated fats, to stay healthy in general. But consider this fatty acid molecule right here, with 3 cis double bonds, and the first of these bonds located 3 carbon atoms from the end of the chain. These are known as omega-3 fatty acids, because the first double bond is located 3 carbons from the end of the chain, right here, and hence omega-3. There are actually several variants of omega-3 fatty acids, but this is one of the most common ones, and it's called α-linolenic acid. Omega-3 fatty acids are essential fatty acids, meaning our bodies cannot make them on its own, but we need them for proper health. They are needed to form higher-order omega-3 fatty acids needed by our brain. They help control blood triglyceride levels, and have been associated with treating some developmental disabilities and mental health issues. Both omega-3 and omega-6 fatty acids are considered essential fatty acids, and thus should be included in any proper diet. They can be found in some fish, especially cold water species, and in significant quantities in kiwi fruit seed, perilla, chia seed, flax, and hemp. So, those are the basics of fats. I know that this video goes into much more detail than our textbook does. You really don't need to memorize all of the chemical details mentioned here, at least not for the class, but knowing the fundamentals, the reasons behind why things are, truly helps me to understand the subject matter much more clearly, and hopefully this information was helpful to many of you as well.